All right, so welcome back to day 4 of Advent of Code. This is the last day that I'll be doing a review for CSCE 155E for your final as well as 155H. So today, again, we're going to be doing day 4, but we're going to be doing it in the C programming language. Right. So here we are. Here's the problem. You arrive at the Venus Fuel Depot only to discover it's protected by some password. So we're going to be probably doing some password cracking here. The elves have written a password on a sticky note, but somehow threw it out. However, they do remember a few key facts about the password. It's a 6-digit number. The value is written in the range given in your puzzle input, and that looks to be down here. Two adjacent digits are the same, so like 22 or 33 or 44, and I imagine it could also be like 555. That counts. Going from left to right, the digit never decreases. They only ever increase or stay the same, like 111123 or 135679. It's always increase. It's non-decreasing, basically what it is. Other than the range rule, the following are true. 11111 meets all those criteria. It has a double. It never decreases. This one does not because 5 goes down to 0, so it's a decreasing pair of digits, so we would reject that as a possible password. 12378 is increasing, but it does not meet the criteria. There's no like 1122 or 33, etc. All right. So how many different passwords within the range given in your puzzle meet these criteria? All right, so I don't have to click anything special here to get the first puzzle. Let's go over to I've already set up some code here. That's my range. So what I'm going to do is I'm going to go ahead and put those into variables because I don't think that that'll change, but in the second part. But I'll go ahead and put them into variables to keep this general. All right. And as we can see, this one decreases, as does this one, so we know immediately that these are not passwords. All right? We were asked how many passwords between these two meet the criteria, but they didn't say whether or not it was inclusive or exclusive. But we already know from just looking at them that that they don't matter because they're not going to conform to the criteria. So we know that those aren't possibilities. We'll go ahead and count up the number of valid here. And I'm just going to go into a loop here. Start at A plus 1 if you really want to. I'll just go ahead and keep it simple. While it's less than B, I plus plus. Right? In fact, yeah, we'll go ahead and do that. Because we know that A here is not a valid password, so we can start one beyond it. We don't have to go up and include B because, again, we know that it's not valid. All I'm going to do is I'm going to put this into a function because I don't want to have. I want to focus on one password at a time. So if is valid of I, then we will increment the num valid, and we'll go ahead and print that out at the end. All right. If only it were that easy. What we actually have to do now is create a function called isValid that takes, say, an integer value here. We'll call it P for password. Right? And it's going to have to look at that password and determine whether or not both of those criteria or all of those criteria are valid. Now, because we started out as a 6-digit number and we go up to a 6-digit number, the first one is already free. That's given to us because we're only looking at the range. The two adjacent numbers have to be the same. Going from left to right, the digits never decrease. They only ever increase or stay the same. So what I'm going to do is I'm going to actually convert this to a string because it's going to be much easier to get each digit and treat each digit separately if it's a string. So remember, we have this function called printf that prints to the standard output. We have a variation on that called sprintf or sprintf that is going to print to a string. I, of course, first need my string. So I will create a statically allocated string called, S, let's say. And since it's a 6-digit number, we need enough room for that null terminating character. So I will make it of size 7. Right? I'm choosing not to make this dynamic in this case because it's small enough. I'd have to clean it up at the end anyway, and so I might as well just let the. I'm not going to abuse the stack space too much with only 7 bytes of data. It's enough, and it's small enough that I can just use a static string here. Okay. We will print into that string. %d is our placeholder for this password here, and we just simply print in the password p here. Right? That's going to do is it's going to enable us to treat each digit separately. S of 0 is going to be that first digit. S of 1 is going to be that second digit, etc. To show you that this works, let me go ahead and print it out. %s and the line, and we'll go ahead and print out s here, and then return 0. All right, and it's going to print out a lot of them, but you can see that it's actually working, right? These are actually string values that I can now manipulate, okay? So let's check the first criteria, that one of these, a pair of these digits has to be the same, okay? Actually, let's do the second criteria first. So check to see if it is non-decreasing. That's the correct term for that. Increasing would mean that it's monotone, that it's actually increasing each time, but non-decreasing means that it can stay the same or it can go up, but it just can't go down. So all I'm going to do for that is for each character, I'm going to check that the next character, s of I, has to be less than or equal to s of I plus 1. Right? Now that is okay, right? If that's not the case, then I know immediately that it's not valid. So if it goes from 5, say, down to 0, then I know that that doesn't conform to the rules. So I'm going to go ahead and just return false immediately. I don't have to do anything else because it doesn't pass that rule. Now, let's check our bounds here. This is going to go up to 5. So 0, 1, 2, 3, 4, 5. That's 6. But remember, I'm going plus 1. So I need to make sure that I stop short here. I'm only going to go up to 5. Here's another advantage of me treating this as a string. Now this is not comparing the actual numbers, like if 5 is greater than 3. Those are not numbers. These are characters, but they have an ASCII text value, right? That is monotone increasing. That's 0, 1, 2, 3. They follow an order, so I can exploit that order and not have to reconvert them back to a single-digit integer. Okay. So there we've got that. Now we need to check to see if there is at least one pair of repeated digits. Okay, so I'm going to go ahead and set a Boolean here. Has repeats, right? And I'm going to initialize it to false until we find a pair that actually repeats. And so I'm going to go ahead and go into another for loop, same for loop as before. Check the first one and compare it to the second one to the third one, all the way over to the end. But I stop short because I don't want to compare it beyond, right? So if s of I is equal to s of I plus 1. Again, I'm exploiting the fact that these are ASCII text values, that they're comparable, and that they would be the same, right? So has repeats would be true. Okay. In fact, what I could do is you can kind of see that it's the exact same loop. Why not collapse those two, right? And I'm going to go ahead and refactor this a little bit. So I'm only going over the password once, right? So at this point, if it's not non-decreasing, then we would have already broken out of this function and returned false. So we know that it is at least non-decreasing. Whether or not it has repeats, if it's true, then we should return true because otherwise we would have broken out of this. If it's false, then we should return false. In other words, let's just pass out that has repeats value. All right, well, let's just go ahead and return that value. Okay. Now let's go back and test this because let's make sure that that this is actually working. And by that I mean that let's go ahead and test it to make sure that the 3 that we were given. Let's see. Let's see if that gives us what we want. I don't want to run through the entire thing until I'm sure that it at least works on those 3 values. Right? So let's see if that's true. It should be true. Yep. Okay. Let's go ahead and check this one. This one should be false. All right. False. Good. And the final one here does not meet these criteria because there's no double. So let's make sure that it also returns false. All right, good. I'm somewhat convinced that this is correct. So let's just go ahead and try it out. I'm not printing anything good, because I don't care about the individuals. So 1767. Let's see if that's my answer, because obviously I don't have any other way of testing this. I guess there are a couple more test cases that I could do up here, but let's see if I'm right. Yeah, I got the right answer. I'm going to go ahead and put that in my comments so that I don't lose it. But of course, you can always go back. It gives you your answer, right? Once you've solved it. So here's part 2. And Elf just remembered one more important detail. The 2 adjacent matching digits are not part of a larger group of matching digits. Okay, so here I was kind of anticipating something like this because I did say if it was 5, 5, 5, that would count, but it would count twice. But apparently that's not allowed. Given this additional criteria, but still ignoring the range rule, the following are now true. So 1, 1, 2, 2, 3, 3, that's still okay because the repeated digits only 2 of them here, only 2 of them here, only 2 of them here. But if we have like 4, 4, 4 no longer meets the criteria, the repeated 4, 4, 4, 4, 4 is part of a larger group of 4, 4, 4. This meets the criteria. Even though 1 is repeated more than twice, it still contains a double. All right, I have to understand this a little bit more. The 2 adjacent matching digits are not part of a larger group of matching digits. But 1, 1 is part of a larger group of matching digits. I think that this could use a little bit better explanation. Given the additional criteria but are still following the range rule, the following are now true. Let's see. Okay. So this meets the criteria. I understand that. This I understand as well because 4, 4 is part of a larger group 4, 4. This meets the criteria. Even though 1 is repeated more than twice, it still contains a double 2, 2. Okay. I'm going to assume then I'm going to translate this to if it's 3 or 4 or 3 or 5, excuse me, then it no longer meets the criteria because if it's an even number of them, like 1, 1, 1, 1, obviously that they're allowing that. I'm not understanding whether or not they would have 1, 1, 1, 1, 1, 1. If that would count as well. So this has a little bit of a muddled kind of description, but I'm going to go ahead and assume that if it's repeated like 3 or 5 times, then we need to say no. In fact, that's not allowed. Okay. Okay. So with that assumption, let's see. Duplicate this. I don't want to lose that. Part A. I'll just leave that there. All right, and I can get rid of this. Actually, no. Let me let me make sure that, for example, this one will be okay. All right, and we can test this out. There we go. All right, so the way that I'm going to approach this is that I've still got all this criteria here, and if it doesn't have repeats, then I will immediately return false. Right? Otherwise, it has repeats, but we need to check to see if it has 3 or 5 repeats. Right? If so, return false. Otherwise, I'll return true. All right? Okay. It's small enough that I could go through it again. So let's do this for 3 repeats, right? 3 repeats, right? Now I'll start at 0, but what I'm going to want to do is I want to make sure that I is equal to I plus 1 and is equal to I plus 3, right? And it's not equal to the 4th one, right? Or that that it falls off and now you're beyond the string here, right? So if s of I is equal to s of I plus 1 and s of I plus 1 is, I could just go, s of I again is equal to s of I plus 2. That means I've got 3 in a row. And I want to make sure that that there's not a 4th here. So and s of I plus 2 is not equal to s of I plus 3, right? Then I've got a 3-peat here, and I need to return false, right? That's, yeah. And now you've got to be careful here, because if I've got a 6-digit number, right, I'll use 3 fingers. If I've got a 6-digit number here, I could have a 3-peat here, a 3-peat here, a 3-peat, all the way until the last 3. So 0, 1, 2, 3, 4, 5, right? So I only want to stop up to and including 3. Right? This is not going to get me into trouble, because this will, at the last iteration of this is going to end up being the null terminating character, and nothing, no valid number is going to be equal to that, so that's going to end up being true. Okay. Do it for 5-peats now. All right. So 5-peats can occur with the first 5 or the last 5. So we're only going to go into 2 iterations of this. Right? And this is going to get messy, but so be it. Right. So there's the first one is equal to the second, second is equal to the third, third is equal to the fourth. So I need 1 more. And s of I plus 4 is not equal to s of I plus 5. Right? So first, second, third, fourth, fifth, but the 5th is not equal to the 6th. Okay? All right. Let's see if this works. I don't have high confidence here, but that's because I don't have high confidence in my understanding of the problem. Right. So is valid. That meets our criteria, so that's true. The second one is no longer meets our criteria, so this should print out false. Okay, well, at least we get that. This should print out true for some reason that I don't understand. Right. Oh, it's invalid. Make sure that I wasn't screwing up here. B. is valid is false, even though it's telling us that it meets the criteria. Even though 1 is repeated more than once, it still contains a double 22. Okay. And I think, okay, now I understand why I'm getting that answer, because on the second iteration of that, we're saying, okay, this is equal, this is equal, this is equal, but then this is not equal, so it's interpreting that as a three-peat, but it's not a three-peat because we've got one prior to that. So one way of fixing that is to look one before. Now my approach is not looking all that great. I'm thinking that I would want to redo this and count up the number of repeats until I have no more repeats. And if that number is 3 or 5, then I immediately stop and return 0 until I get all the way to the end. So that might be a little bit better, a little less brittle here. I could, of course, always look back one and see that it's not equal as well, but that's really brittle as well. And also then I would have to take care of the fact that when I start out at the beginning of the string, I can't go to index -1. Okay. All right. So let's go ahead and iterate over all of them, like we did before. 5. There we go. And let's rethink this entire thing. Okay, good. All right. So I might actually want to do a while loop here instead. No, I'll do a while loop on the inside here. All right. So I'm starting out at at character s sub I with a counter of, say, 0. So int count is equal to 0. We're going to want to count the number of instances. So if we start out and we've got 1, 1, 1, 1, 1, I want to keep a counter until the next one is not equal. So while s of I is equal to s of I plus 1, I want to go to the next character, and this will take care of this at the end of the loop to go to the next character. But what I want is, I'm looking at 1 right now. The next one is 1, so increment to that next one and increment your counter, or count. Right. Now, once you've broken out of this, so 1, 1, 1, 1, we're now at this 1 and we've broken out, and there's that 2 now. And so I have counted this up, and I counted it up to 4, I believe. But we can go ahead and printf %c appears %d times, and the line, I'm going to do this for debugging purposes. S of I, right? And that's the character, and then the count, right? And that looks good for debugging purposes. Let's go ahead and go back, and 1 appears 3 times, 2 appears 1 time. We're off by 1 here. Yeah, so I need to start my counter at 1, right? Because if this while loop never executes, then 1 is not equal to 2. Say it starts out at 1 and then goes to 2. 1 is not equal to 2, but I've seen 1 once at least, right? So run this. 1 appears 4 times, 2 appears 2 times. We can test these out here with the other values. So I should get 4 appears 3 times. Right? Okay, and the others appear 1 time. Good. All right, so I'm convinced that my looping structure here is correct. And now I just have to make sure that my criteria for rejecting this password is correct. So if the count is equal to 3 or the count is equal to 5. This is again. This is my understanding, maybe misunderstanding of the problem statement. But if you see 3 of them, then no, that's not allowed. If you see 4 of them, again, one reason I have confusion here is that 4 of them is okay if it appears at the beginning or at an even index. But what if it were 2 1 1 1 2? All right, so 2 4 ones and then a 2. Does that count as well? And it wouldn't count because of the decreasing 2 down to 1. But what if we had 1, then 4 2s, and then a 3? That would seem to indicate that would be a valid password, but I'm not sure. Right? So if it's 3 or if it's 5, certainly, then this is a bad password, so we'll return false. Otherwise, we return true. Okay? So, again, oops. What are we testing here? Is valid is false? Okay. That jives with at least the ones that they gave. Right? Is valid is true. And now this one, again, that I'm not quite sure I understand their meaning here. It's valid, right, according to my understanding, at least for this one. So let's go ahead and just pull the trigger, and if I'm wrong here, then it's because of my misunderstanding of the problem, probably not because of my programming, but 1044 seems to be the answer. That's not the right answer, that's too low. All right, so I'll document that is too low. And unfortunately, I'm not going to be able to determine what's wrong here. I could, print these out that printf %d is valid, or I'll just go. Oops. There we go. All right. That's telling me that that's invalid. If I search for another 5, invalid, 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 invalid. When I get down to 4 5s, I'm saying that that's invalid. Oh, but maybe that's why. That should be valid, right? So let's actually go ahead and oh, it's invalid because it's going down. You know what? Let's go ahead and test it for one of the examples that I was talking about earlier, where we've got, say, 1 and then 2 2 2 2 3. Right? That's non-decreasing. It's got 4, so we wouldn't reject it. Again, I'm not sure that we should reject it, but let's go ahead and run this again. And it's going to say that it's valid, but that's by my reading of the program, that is valid. And another hint here is that we're counting too low. So, I mean, even if we are counting this as valid, but they're not, then that would mean that I'm overestimating the number of valid passwords. So it's definitely not this misunderstanding. It's just a misunderstanding elsewhere. So at this point, I'm going to have to go ahead and admit defeat and come back to it later. Maybe read a little bit about it on the subreddit to see if other people have had the same clarification issues. Maybe somebody else can clear that up. But otherwise, at least we walked through how to go about doing it, at least in C. And if you have any issues, or then if you have any questions or you can go ahead and post it in a comment, but otherwise I might, if I can get it later today easily after reading about it, then I'll go ahead and post what my misunderstanding was. All right. Thanks for joining me, but otherwise this will probably be the last time I do this. This is day 4, and your final exam for CSCE 155 E and H is next week. Thanks for joining me for these review sessions, and good luck on your final, and good luck on all of your other finals as well.